Reference angles, why are they useful and where are they located? Reference angles are all located in quadrant 1. Because if I reflect any of those angles, I'm able to know all the x and y coordinates of every single other angle. So if I know 1/4 of the circle of the x and y coordinates, I know the entire circle. And why are they useful? They allow me to find trig values of any angle I'd like. So for example, 30 degrees, you drew that earlier, had that on the Discovery 5. And if you take a look at this, this had the ordered pair about 0.87 and about 0.5 or a half. Now, if I reflect that, it's going to come over here and form a new angle. And so the reflection off of my x-axis forms the same ordered pair, except for the x-coordinate of that 0.87 is negative and the y-coordinate 0.5 is positive. So that 30 then becomes all the way around to 180, back up 30, becomes that 150. Likewise, instead of always calling this 180 degrees, we might call it pi. Well, pi is just a whole number, and in terms of this, I might want 6 pi over 6. So if I'm backing up 1/6, I would be at 5 pi over 6. So this is kind of what we did earlier in the lecture, and that same thing works with 45 and 60 degrees. But again, you have to understand here that in quadrant 2, here's 1, and typically we do it in Roman numerals, quadrant number 2, the x value is negative and the y value is positive. In quadrant number 3, both x and y are negative, and in quadrant number 4, it looks like my y is negative, but my x is positive. Those are going to become very important soon. So if I wanted just to go around the circle and find my reference angles, if I went to 60, go all the way to 180, back up 60. Go all the way to 180 and another 60. And lastly, go all the way around the circle, back up so you're in quadrant 4, and you have 300. Typically, the fractions are a little bit more complex, but again, if I'm looking at pi over 3, I'm looking at 3/3. So I go to 3/3, I back up 1, I go to 3/3, and I go forward 1, and that 1 is 1/3 pi. And lastly, if I go all the way around the circle, that is 6 pi over 3, which is 2 pi, and I back up 1. So these angles are the ones that we are going to use often. So if I want 150, I need to know the angle it came from in quadrant 1. I need to know the angle it came from in quadrant 1. So what I'm looking for is how much did I back up to get me into quadrant 2, and I backed up 30 degrees. So 30 degrees is the reference. If I know 30, then I know the 150. If I'm in 230, I'm at 230, so I'm saying, well, how much more did I go than the 180 to drop me in there? And it looks like I went 50 degrees, so that's an angle we haven't looked at yet. 310. So I'm wondering, if I draw my angle 310, how far back to that axis am I? Because that's the angle that would have been reflected down, and I went back 50 degrees. Let's try it in fraction form. So again, I'm at a full pi, which is 4 pi over 4, and I went back. So pi over 4 is my reference. And what is pi over 4 in degrees if I want to convert it? Well, now pi is 180. 4 into 180 is 45 degrees. Let's look at 2 pi over 3. Again, now I'm in thirds. So you have to know a little bit about your fractions. I went back pi over 3. So pi over 3 is my reference angle. And if I wanted in degrees, 180, that's pi, divided by 3 is 60. And lastly, if I'm at pi over 6. Let's see, my bottom denominator is 6. So this would be 6 pi over 6. This would be 12 pi over 6. So I can see 11/6 of a pi is in quadrant 4, and it is pi over 6 back to my axis, which is 30 degrees. Pi is 180. 180 divided by 6 is 30. So you're going to want to know 180 divided by 6, 180 divided by 3, and 180 divided by 4.